Now we have a special presentation by Satyajit. I have already introduced him twice, so no need for his introduction. I think his topic will be transformative synergy, advancing sustainability and energy security through AI innovation. Over to you, Satyajit.
Thank you very much. In cricket, it's called hat trick. So 3 sessions together. Congratulations to me. But I would say that this is a very interesting times of our journey that energy sector is seeing, and why we call it very, very interesting is because there are many challenges that this sector is facing, and as a whole, the globe is also facing. So, if I were to start, I took this picture from World Economic Forum. And this is a snapshot of global risks that we are seeing in the world today. And if you really were to look at it, it's all about uncertainties across a long term. And when we look at this picture, we would see that there are many constraints that are coming up, whether it is natural resource constraint, whether it is supply chain constraint, whether it is extreme events, number of extreme events have increasing. So in a way that we can look at it is that there are large number of extreme events, uncertainties are creeping up in our world today. And that is what energy sector needs to be aware of, needs to take cognizance of it when it looks at its planning and its modernization and its thinking rather. And in the mindset that one of the speakers also had highlighted. The second thing that we are looking at it is these uncertainties or these changes that are happening across the world has having different dimensions. If you look at it, number of extreme events in India has grown up significantly. There are talks about renewable energy. Obviously, India has a very aggressive plan and it's a leader as far as renewable energy is concerned as well as EV is concerned. But overall, if you look at it, there are climate change issues that are coming up into play, and that needs to be seen it because there is different kinds of world that we are seeing. One is talking about that fossil fuel is a fantasy, and the other side we are pushing up renewable energy, electric vehicle adoption in another part of the geography. Though obviously going forward there could be inter-regional difference of perspectives that will come up into play, and that might have an big impact on energy security per se. That is one side of the story, that the uncertainty will become even more uncertain going forward. The other aspect that I think in the first presentation that was shared is customer engagement. I think one of the important elements that energy sector should realize it that with telco, with banks getting adopted to those kind of retail sectors, other digital initiatives that other sectors are looking at, the future energy customer, any transformation that we need to do needs to be looked at from a future customer point of view. How this customer will move, how this will be looked at. And there are 4 characteristics that we call it these customers will be. One will be they will be demanding digital trust, and we had demonstrations of cyber security. We had demonstrations how IT/OT architecture needs to be built up. But this digital trust has to be built up before we embark on. And there was a brief mention about data monetization, but obviously it is built on this digital trust that we can embark on and provide it to the citizens or to the customers. That is very, very important. Second is loyalty, and that will come from digital appreciation and usage and delivering value-added services. Now we are rolling out smart meter data, and it is going to give us a lot of information about your consumption. But are we using smart meter data to know the appliance level details of customer? Are we able to give them, we are only giving them time of use tariff, but are we able to give them recommendation that 6 to 7, you always use your washing machine or 2 washing machines and 1 air conditioner. You need to switch these things or move your load to some other time frame. So to what extent we want to leverage smart meter data is dependent on us. It's not just having for a specific set of purpose that, we want to record a better max demand or we want to capture harmonics. It is not that. With harmonics itself, you need to look at various other aspects that can even pinpoint to what appliances the customer is using. And this is what, non-intrusive load disaggregation is a capability that is coming up to use with smart meter and even advanced data loggers. Because unless and until we know the category, unless and until we know the appliance level usage, we will not be able to really take the full potential of the smart meter data. The third thing is agility and automation. And there are various techniques that are coming up. There are emerging technologies that are come up. And one of the technologies that is changing the landscape is Gen AI. I mean, today customer really needs to have very simplistic way of getting insights, inputs, feedbacks, confirmations from the utility. So even within, whether it is customer or within the internal customer itself, whether it's a maintenance official, in a plant, in a distribution unit or in a transmission unit, they would like to simplify their lives in getting insights from the data, from the analysis, from the regular AI that is there. And Gen AI is actually shaping this entire landscape. There are pathway to do that. It is not, it's not a magic wand that today you roll out Gen AI and tomorrow you will get the benefit. But then these are some things, emerging technologies, which is changing the behavior of the customer, both external and internal, and their expectations as well. So one needs to look at that. And then green living. I mean, whether we talk about energy efficiency, whether we talk about renewable energy adoption, whether we talk about, demand response management, these are mostly driven by data-centric initiatives. And therefore, one needs to be very clear in mind that when I'm doing my transformation, I'm looking at a grid, but I should also look at a customer as highlighted in the previous session. These are the two levers that I would call it that will drive going forward and in more intense way. The third thing that will be very, very critical is financial sustainability. And this is having a lot of discussions and more focus in India because obviously over a larger history we have AT&C losses which were very high. We did not have GX indexing which had hampered. We did not have meters, distribution transformer meters. We did not have even SCADA systems to a large extent in the grid. But over a period of time we have built this IT and OT systems. Now we need to look at how do we move in the utilizing this data to improve our collections? How do we need to use this data to reduce our non-technical losses? How do we need to address, optimize maintenance and operations cost? And how do we need to look at average cost of supply, whether it is related to power purchase, whether it is related to energy efficiency, whether it is related to simple spare parts optimization, in power plants. This is one of the biggest area that we have seen that 30% of, we are doing an exercise, we saw that $18 million can be saved in inventory of a size of where 600,000 items or spare parts were managed. So $18 million in a year. And that is huge. One way we are saying that we are having issues with cash. The other way we are saying that we can leverage $18 million reduction in spare parts inventory itself. So one needs to see it that wherever there is a potential, that's why it is very, very important that if you are a generation, transmission, distribution, or you're distribution alone or a transmission alone, one needs to really look at these elements, both CapEx and OpEx and revenue, to be seen as to where we can apply data analytics and AI to be able to leverage it, because we have seen that many inefficiencies are there. The data is there. The inefficiencies are there. But under the context that, we do not have systems to build this, we leave certain white spaces where it could be leveraged, where good data is there, and you could actually benefit out of it. So taking these three things into consideration, our focus area is across 4 themes, basically in utilities side, whether it is planning, whether it is operation, whether it is asset, and whether it is customer. Now, if we look at this 3 dimension, it will cut across the value chain, generation, transmission, distribution. But it is very, very important to see that these are use cases that we have sources of value that has come up with existing systems, existing industry members with their existing source systems that has been there. And obviously there are upgrades that are happened which come along, but these are the sources of values that comes up very, very, in a big way that we see utilities in India would be leveraging it going forward. But one thing that we have seen is that these use cases are on experimentation mode many a time as a pilot or a proof of concept, and these are driven by multiple technologies. Now what happens is when you have multiple technologies rolled out for many different initiatives, and then you want to centralize it and try to achieve an enterprise scale, you have challenges, in that. Because there are issues in model management, there are issues in knowing what models have been built, there are issues in knowing the life cycle of the models, the outcome of the models. I had been in a plant which had rolled out 60 machine learning models on open source. And the team which had rolled out had left within a span of 3 months. Obviously, they were, they got acquainted, they learned it a lot, and they left the company. Now, when I asked the CIO, now what are you doing? Now I'm spending my next 6 months to ascertain what was done. Now this is what is a challenge today. Now if you build up certain scale of open source setups or any of these, till you are doing an experimentation mode, till you are testing up a concept or a hypothesis, it looks good. It is fine because you do not want to invest more. You do not want to really boil the ocean to get it. Maybe it is good. But when it comes to steady state, when you want to roll it out, because building models and keeping it my desktop is building my inventory of my models. It will not pay you anything. Unless and until that model is deployed, running on your data regularly, it will pay money. Otherwise, it is academic interest. I can build a model and I keep it in my folder and be happy about it, publish a paper somewhere, speak about it in an event. That is fine. But the question is your AI paying? Is it paying on a daily basis? That is what is the ultimate test of any kind of analytics exercise that you want to do. And this will be important because on a steady state, because what I consider is there is a bimodal operation of any system. It will be experimentation or steady state. Experimentation, you can go in a particular way, but a steady state requires an enterprise scale. Without an enterprise scale, it will be very, very challenging for you to really continuously get the outcomes across various usages. So these are some of the challenges that we have seen. Analytical governance is a challenge. Managing portfolio of diverse technology is a challenge. Suboptimal technologies, because you are in a rush, you pick up something, you build a model, show the concept, go to your leadership, get the grant. But now what? What should I do now? How do I reach it to all my plants? How do I reach it to all my distribution units? How do I reach to all my network? It becomes extremely critical to have an enterprise thinking in the mindset, and that will be where you can reach a steady state. So for that, one needs to look at it from a point of view that from data to decisions, because decisions drive organizations, not data. Okay? Data you can accumulate. We can feed ourselves with as much food as possible. But unless and until we utilize it, we will only become sluggish, right? If we eat too much of data goes into our stomach, we will become sluggish and slow. But am I energetic? Am I able to harness it and generate energy at the right point of time? Am I able to run 10 kilometers or 20 miles? That will depend on how you are utilizing your food, how you are changing it into that dimension or to that context. So it is very, very important to build this bridge, because from data to decision, it's a journey. You need to build the bridge. This bridge will have multiple aspects, multiple contexts, whether it is planning, whether it is, power, whether it is, customer, whether it is plant, anywhere. You need to build this bridge. And this bridge is the AI part. This bridge that generates this insight that will enable you to take right decisions, informed decisions, accurate decisions is the pathway that you need to look at. And it goes through 3 phases. One is obviously managed data. Managed data includes treatment of data quality for a specific context. Do not remove data quality from the context, because you will be doing data quality throughout the life. You will never come out of it alive. Okay, because data quality is such a subject. If you remove the context out of it, I can bet I will give 80 GB of data and I can recruit 80,000 people to do my data quality of that data. They will take 80 years and still never come out of it alive. Because if you add a context to that, then the data quality makes much more sense, identifiable, curable. Because you don't want to identify, you need to cure it also. You need to put a treatment also. You need to see that bad data doesn't creep into my system and the right treatment is done. So unless and until you add that, that will be the managed data. Then you need to develop model. It is not about one model. It's not about two model. It's not about three model. It could be thousands of model. We had estimated in a power plant, in a true steady state, if they exhaust the use of AI, can you imagine how many models they were supposed to build? Just a wild guess. How many AI models would be running in a power plant? Any wild guess? Louder? 10? 15? 20? They were supposed to run 6,700 models. 6,700 models in a power plant. AI models running. And that too with addressable 80% of the systems. Okay? So 6,700 models, many variables, many models, different kinds of models, deep learning, machine learning, time series, many aspects will be there. How will you manage it? It becomes very, very critical to do that. Second is deploying these insights. Because deploying these insights will require real-time deployment. Some may require batch deployment, some may require weekly deployment, some may require integration with various systems. How will you do that? So unless and until you deploy, you don't get the returns. So this cycle of data to decisioning needs to be managed in a platform that can really give you the capabilities with a single interface that we need to look at from data to decision with a single setup. So few examples from here that I want to look at it is that when you want to build the foundation, you need to look at results you can trust. You can need analytics you need delivered. Whenever you need to be able to deliver. Now forecasting, I had spoken about it, why it is important. Obviously this is extremely critical. But what drives this setup is this frameworks. What drives this setup to have a digital platform that will give you this capability, whether we heard about peak load management, whether we heard of demand response management, these capabilities with a digital scalable enterprise architecture integrated with open source will actually give you the benefit that will be realized. And we have done that. We have done that for many global customers, including India, and they are able to better manage extreme conditions because this is important. Peaks are important, and if you don't estimate peak properly, the other things don't really follow through. And you also have returns at the end of it. No, it is not that you are doing forecasting for the sake of it, but at the end of it, the return on investment should come into play. And this is one of the utilities had benefited out of that. And this is another area, innovation. One of the topics that we are doing is Grid Guardian for, substations and equipments where partial discharge, you can monitor with the real-time IoT devices. You can build, based on the signal, you can apply AI and you can find out where in your network is having a problem with mobile, devices running through the streets of your city. You will be able to know it from the harmonics that we are looking at or the signals. And we have talked about smart collection. This is extremely important because today we have one size fits all collection strategy or a community strategy, but we do not have today a credit score for utilities, for customers specifically. If you don't build your credit score of customers, then how will you collect it? How do you differentiate from a good customer to a bad customer across a particular set of issues? We cannot just rely on aging analysis and then go around and treat the same set of customers, 20,000, 10 million customers in an aging bracket of 31 to 60, and we want to do the same strategy for them. It will not work. The collection strategy will not pay you the debt recovery that you want. So these are some of the elements that we have done in various utilities as far as globally it is concerned. These are based on meter data, monthly meter data, smart meter data to 15 minutes interval to 30 minutes interval to the AMR infrastructure as well. So with that, I would like to end my slide that as far as the AI or the analytics maturity is concerned, one needs to immediately identify. I think this is a request to the regulator specifically to see that, identify, create a journey that you need to look at AI use cases, where all it will be applied, how can we build up plans for that, how can we set up a AI center of excellence, And that center of excellence will take them through the path from forecasting to predictive model to optimization and to complete automation of the AI setup when we are looking at intelligent substation, intelligent grids and smart grids, and revenue, improving our revenue collection. So that is the maturity level that we want to do, but the start has to be now, because nothing is perfect, but there are some quantum of benefits that you can keep adding, and the AI will automatically pay for itself as far as the outcome and benefit is concerned. So with that, I end my presentation. We have a very large footprint across the globe, and we bring that expertise into that, and we'll be happy if you want to come to our booth to discuss further. Thank you so much.
Thank you, Satyajit, for illuminating us about the measurable, the ROI measurable on AI deployment, especially for the power sector.